In this video, we'll review some basic trigonometric identities by way of a problem. So we've done problems like this before where, say, we know that a particular trig function, in this case we'll take cosecant theta is 5/3, and we're also told that tangent of theta is 3/4, and what we want to do is find the other four trig functions of theta. Now we do not actually know what theta is here, but we don't need to. So in order to get started on this, there's a couple things that we can immediately realize. The first is that because both of these are positive, we know that theta must be in quadrant 1. Tangent's positive in quadrant 1. It's also positive in quadrant 3. But cosecant, on the other hand, which is like sine, is only positive in quadrants 1 and 2. So the overlap is quadrant 1, and that's where the angle's got to be. Okay, and so if we want to figure out, say, let's start with sine of theta because it's the easiest, we can know that cosecant of theta is the same as 1 over the sine of theta. And so if we have 5/3 equaling 1 over sine theta, then we can just flip both sides over and we'd know that 3/5 equals our sine of theta. So that one's pretty easy. We still need to figure out cosine and the rest of them. So let's look at cosine. There's a couple ways that we could go about doing this. So one way you might think is to say, look at, oh, well here tangent theta is 3/4, and that's sine over cosine, so sine must be 3 and cosine must be 4. And that's wrong because sine and cosine can never actually exceed 1. So that trick doesn't quite work. We'll have to do something else. One thing that you can do is we know that whatever sine and cosine are, if you square them, and you add those things up, then you get 1. And the reason for this is because it's basically Pythagoras' theorem, and because we defined this as being the y value of a point on the unit circle, and cosine being the x value, the equation of the circle is this with the trig functions plugged in. So we know that's true. We also happen to know sine theta because we've already figured it out, and so we can solve this equation for cos theta. Cos theta is, strictly speaking, it's plus or minus this, but in our case, it's only going to be one of them. Okay, so it never actually is both plus and minus simultaneously. It's just that in some cases it's plus, in other cases it's minus. In this case, we know that it's got to be plus because we said that the angle lived in quadrant 1, and cosine is positive there. Okay, and so if we plug our 3/5 in here, then we get 9/25 when you square it, and then take away from 1 and you get 16 25ths, and then so we've got square root of 16 25ths, and then that would be 4/5. Okay. Now another way that you could have gotten that, by the way, would be, let's actually go back over here to the fact that we know tangent. So we know that sine of theta was 3/5, and we know that tangent of theta was 3/4. And I know that tangent theta equals sine of theta over cosine of theta. And I also know what tangent is. So I have an equation now. Tangent was 3/4, sine was 3/5, and whatever cosine needs to be, actually I'll just write it cosine theta, is whatever value makes this equation true. And if you just cross multiply and clean up the fractions a little bit, then you get cos theta equals 4/5, just like we did before. Okay, So you could, sometimes come about this from two different directions. This way was maybe a little bit faster, but not super substantially. Okay, so we figured out sine and cosine of them, and then the other two are pretty easy. So if we know that cosine is this, then cosecant, or sorry, secant, we already know cosecant. Secant is just the reciprocal, and so we get 5/4. And then lastly, we know that cotangent is 1 over tangent, and tangent was 3/4, so this must be 4/3. So we've got, if I'm counting right, all 6 trig functions, and that wasn't so bad. So in class, what we'll look at is sort of more exotic trigonometric identities. The ones that we've used here in this problem have been relatively basic ones. For example, that tangent is sine over cosine, or this version of the Pythagorean theorem, or knowing that secant is just the reciprocal of cosine, and so on. So those are pretty basic identities, but there's a lot more exotic ones, and we'll start looking at some of those in class.